What's going on, you guys? So today we're going to work on Pascal's Triangle. So we have to make a function generate that will generate the first num rows of Pascal's Triangle. So if we get, for example, 5, we want to generate the first 5. So 1, 2, 3, 4, and 5. So this little graphic is suggesting one way to do it, but we're going to do it a little bit differently. Let's see. So the first is going to be 1, right? And if we just add 1 to the left, we go 1, 1, and that's going to be the second. And then if we add 1 to the left again, we're left with 1, 1, 1. But we need to update the middle, right? Because the middle is supposed to be 2. So how do we do that? If we update the middle plus its right neighbor, then we'll get the correct amount. Okay? So we're going to add a new row every time by adding 1 to the leftmost side and then update the middle values, right? Because the first and the last value will always be 1. So we only need to update all other values. And how do we update all other values? We add the right neighbor to itself. So 1 plus its right neighbor is 3. 2 plus its right neighbor is 3. And we don't need to update the last one because we're not updating the first or the last. Okay, so let's do another row. So we copy it, we add 1. We don't update the first. The second, we add its neighbor, 4. 3, we add its neighbor, 6. 3, we add its neighbor, 4. Okay, and we could keep going. So we add 1, and we for the middle values, we add its right neighbor. So 1 plus its right neighbor, 5. 4 plus its right neighbor, 10. 6 plus the right neighbor, 10. 4 plus the right neighbor, 5. Okay, and so that's the idea behind what we're going to do here. And let's think about time and space complexity. So let's do pseudocode so we can figure out time and space complexity. So for I in num rows, 0 until num rows, we're going to, well first we need to create a result, which is going to be a mutable list of lists. And we're going to create a row, which is a mutable list of int. Okay, so let's think about this. For each I, we're going to add 1 to the left. Row.add, and we can give it 0 as an index and 1. So that's going to add 0, or that's going to add 1 at the 0 index, or to the left on every iteration. So we're going to add 1, and then we're going to update the middle values. So for j right, we're not going to do 0 because that's always staying the same. And we're not going to do the last value. So row.size minus 1. So j, the last value for j will be row.size minus 2 because until is exclusive. So in this case, 1 is row.size minus 1 and 5 is going to be row.size minus 2. So this value here will be the last one that's updated. And what are we going to do? We're going to set row dot set, we're going to set j to itself, row j plus its right neighbor, right? So row j plus 1. And then we're going to result, we're going to add row. Actually, you know what? We're going to add a copy of row, because so we change row every time by adding 1 to it, and the final result will be like 1 5 10 10 5 1 or 1 4 6 4 1. If we just add the same row instance every single time, at the end we'll so here we've made a triangle, at the end we'll make a square, because even the first value will get updated. So it'll look something like this. It'll look like that in the end, instead of the triangle that we want. So that's why we need to create a new instance. So we'll say like new row equals row dot copy, and we'll add new row. We'll do something like that. Okay, so now let's translate that to Kotlin. And we need to comment this out. Okay. Okay, so this is going to be a var. This will be in parentheses. This will be down there. This will be in parentheses. Okay, so let's think about this now. Okay, so in Kotlin, we can do this by calling ArrayList on our row. So what happens there? So that creates a new instance with all the elements in row. So if you look at the constructor for ArrayList, well, first of all, note that ArrayList is a mutable list, which is what we're using here. We're using a mutable list. So all these are instances of the list class. So when we give it a collection of elements, it creates an array list filled from the elements collection. So it's creating a new instance. So we're gonna give our row to ArrayList and create a new instance. So that way we don't get this issue that this is the issue. If we don't give a new instance and we just give the same row instance, we'll get something that looks like this in the end. Okay, and then we want to return the result at the end. Let's see if that works. Okay, that works. So let's think about time and space complexity. So we've got the first for loop. It's going to loop over num rows. So it's going to be O of n. And then the second one, worst case row.size, that's going to equal num.rows. So this is going to be O of n squared. So not super fast. Is there any chance to optimize this? We could. So if you take a look at the binomial theorem, it's a way to give us these constant values. So Pascal's triangle, that's just the constants in front of like the expansion of a like x plus y to the n formula in the binomial theorem. So n to the 0 is going to be 1, n to the n is going to be 1. And so these n choose n minus 1, these values correspond to the values in Pascal's triangle. So if we could calculate these values, we wouldn't need to do the double for loop. So on the first, but this does involve factorials, which take a long time to calculate. So on a first run, this would take a long time, factorial time. But if we save values in a cache, then on subsequent runs it should be a little bit slower. So this is maybe an opportunity to do better than O of n squared by using the binomial theorem. So go ahead and check that out if you're interested. All right, guys, that has been, oh, and space complexity, sorry. Let's think. So we're only calling generate once. We're using 2 instances of mutable lists to hold our result in the row. Oh, we're creating n instances of array list. So is this O of n, space complexity? We have to do it because otherwise we get a result that looks like that. Yeah, so O of n squared time complexity. O of n space complexity. Let me know in the comments if you guys get anything different for time and space complexity for this algorithm. All right, you guys, see you next time.